Hey everyone, welcome to Summer Lecture 1.3. This is on unit analysis. So this topic is very important because it comes up in every single unit that we do. Understanding what units you're trying to solve for can help you solve a problem that you actually have no idea how to go about. Case in point is the class that just graduated, class of 2015-16. They said when we were going through the review, there were some things that there's just so many formulas they remembered they couldn't solve a certain problem. So they did their unit analysis, they got the unit that they knew they needed, and it gave them the right answer. So if there's a time that you get stuck, unit analysis can definitely help you out, and it's extremely, extremely important. We're going to harp on it the entire year. So all measurable quantities are represented by at least two things: an amount, so some type of number, and a unit. What I mean by that, your speedometer. If you're going 60 miles an hour, that's 60 units of length, which in this case you guys are using miles, over 1 unit of time, which is an hour. So our base units that we're going to use are length, time, and mass. And in the SI units, the base unit of length will be meter, the base time unit will be seconds, and the base mass unit will be grams. So you can obviously make these bigger, smaller, like a kilogram would be thousands of grams. A megameter would be millions of meters. So there's lots of ways to go at it. But the two examples I have down there are area. So if you're going to measure the area of my backyard is so many feet wide by so many feet long. I take the length times width. That's a length multiplied by another length, and I get length squared. If I needed a volume of a pool, I would do length times width times height. I multiply those three lengths together and get length to the third power, or cubic length. So for you, it depends on what you're looking for. If you're doing this all your measurements in feet, you're going to get square feet or cubic feet. If you're doing it in meters, you're going to get square meters or cubic meters. So just be careful on making sure all your units are similar. And in saying that, that's what I mean by here with units in formulas. When you guys start deriving formulas from your experiments, and you got to make sure that all your units match up. So say there's a formula that we created. Say the formula is A equals B plus C. If A has a certain unit, and you look at B and C must have the same unit. So the first example there, it says if the units of B are length per time and the units of C are length squared, that means absolutely nothing. All formulas and all units must make sense and match up. So in this case, a length per time, like we said, is a speed, and a length squared is an area. Adding a speed and an area means absolutely nothing. So it's got to make sense when you're creating your formulas. And somewhere that you can get tripped up is if you look at the second example, it says that B is length squared and C is also length squared. So you've got both B and C having length squares, but make sure that those variables are the same. Like I said with my backyard, you've got to have square feet add up to square feet. You can't have square feet add up to square meters. That just doesn't make sense. So make sure the units match up every time you do that. And this is what I mean by my class last year used unit analysis to solve problems they had no idea doing. They knew the formula, maybe A plus B, but they just couldn't get that final unit. So they used the unit analysis to show that A must equal square length, and the only option in the multiple choice was something with square length. So that's the answer they picked. Think of that next time you do it. And the last thing we have in here is prefixes again. You can refer back to the estimations video that I had, and we can use these prefixes like kilo for things that are thousands. Things that are in the millions are big M for mega. Things that are in the trillions are big T, tera. And you can go smaller with the milli, micro, nano, pico, and so on. One of the examples from the homework, number 6 on web assignment for this one, wants you to write everything in just their units. Not how many, no numbers whatsoever, just the unit. So the base unit of mass must be a gram. The base unit of time must be seconds, and the base unit of the length, since we're in SI, is going to be meter. When you do that, if the example calls for length of a day, the length of a day may be thousands of seconds. So your answer would be kiloseconds. That's it, KS. If the length of a day is millions of seconds long, then it's big M, little s for megasecond. You don't have to put a number with it, just do an estimate and then write what prefix that you put in there. So unit analysis is a great way to help you solve problems, like I said, that you have no way of solving for. If you have any questions on it, please refer to the 3 examples I do and let me know if you have any questions.